Hi, once again, everyone. It's Professor Sebastian. Welcome back to our statistics class notes. We're at the very bottom of page 78. Just to introduce, I quickly talked about a discrete random variable before, but let me talk about the definitions of these guys, the difference between a discrete random variable and continuous random variable. So a discrete random variable is a random variable where the numerical values are such that you can list or count them. A continuous random variable cannot be listed or counted because they occur over a range of values. Okay, something like heights. You can't list every possible height between 5 feet and 7 feet or something like that. So they can't be listed or counted. They occur over a range of values. They have to be measured. Discrete is you can actually list or count all the different possible values. Okay, so for example, here I want to, in this example, determine if the following numerical random variables are discrete or continuous. So the number of siblings any person has, that's discrete. You can count the number of siblings, the brothers, sisters that you have. The height of basketball players, that's continuous. That probably ranges somewhere between 5 feet and 8 feet, right? So the bottom line is that you cannot list all the possible heights in there, so that's continuous. The number of cars owned by a household, that's discrete. We can certainly count the number of cars owned by a household. The number of pets owned by a student, that's also discrete. We can count the number of pets any student owns. The height of a building in downtown San Francisco, that's also continuous. We have to measure those as they occur over a range of values. We cannot count the different heights. And then wait times in a doctor's office, that's also continuous. We cannot list all the possible times you'll have to wait in a doctor's office. There's an infinite number of them. So when you break it down and keep breaking it down and keep breaking it down. So in other words, it occurs over a range of values, so we have to measure how long we waited. Thus, it's a continuous random variable. Now, since the values of a continuous random variable cannot be listed, a probability distribution using a table, like we introduced for the dice, or a spike graph like we introduced for the number of stars a book reviewer on Amazon might give, those can only be used for a discrete random variable. Okay, so we cannot use them for a continuous random variable. Instead, the graph of a continuous probability distribution is called a density curve, or sometimes PDF, which stands for probability density function. These graphs have an area under the curve that must equal 1. So the area under the curve equals all possible probabilities summed up. Therefore, the area under the curve over a specific range of values represents the probability defined as the probability that x is between a and b. Right? Probability a less than or equal to x is less than or equal to b. It's saying x is between a and b. So for example, the probability density curve here to the right shows the probability of wait times before you get service at a coffee shop after you walk in through the door. So the shaded area represents the probability of a wait time between 0 and 2 minutes. The total area under this entire curve, so here's the curve, the total area in there has to be 1 because it takes into account all possible wait times. Now, when I'm looking at that curve, what's the minimum waiting time at the coffee shop? So you can see that it starts at 0, so that's the minimum waiting time. That's like you walk in the door and no one's there, so you can order right away. And what's the maximum waiting time at the coffee shop? This coffee shop is, the data here is telling us that it comes back down, the probability density curve comes back down to 0 at 5, so we're not going to wait any longer than 5 minutes. Now, based on the graph, approximately what is the probability that someone will wait between 0 and 2 minutes? So what we would have to do is we have to find the area here between 0 and 2 minutes that lies under the probability density curve, probability density function. So finding that area is not possible. We're just estimating it right here. We can't find the area under such a thing unless we had calculus ability and we knew exactly what this function was, so we're not doing that. So we're just estimating it. It looks like it's not quite half, but maybe around 40% of the area under the curve. So that's an approximately 0.4 probability, or 40%. I'll come back to the next example in the next video.